So now we want to talk about graphing rational functions in general. So we're going to let f of x equals p of x over q of x, where p of x and q of x have no common factors other than 1. And we're going to assume that both p of x and q of x are polynomials. So first thing, we're going to determine the x and y intercepts. And then determine if the function has vertical asymptotes and graph them as dashed lines. Determine the function has a horizontal asymptote or a slant asymptote. Again, anytime they ask us for a slant asymptote, there's not going to be none in this course. And graph the asymptote as dashed line. Determine if the function crosses the horizontal or slant asymptote. We can use our test of symmetry. We have y-axis symmetry and origin symmetry like we talked about before. And then plot at least one point in the intervals defined by the x-intercepts, vertical asymptotes, the points where the function crosses the horizontal asymptote or slant asymptote. Now, one thing I want you to keep in mind as you're doing this, and whenever you've got your function, just remember, the x-intercepts come from the numerator. And the vertical asymptotes come from the denominator. X-intercepts you get from the numerator, vertical asymptotes you get from the denominator. Alright, so let's go ahead and try some problems. So here we want to go through and we want to graph these buggers. So we're looking at x minus 2 over x plus 3. So again, I'm just trying to keep in mind that's going to give me my x-intercepts. That denominator is going to be my vertical asymptotes. So just keep that in mind. So my x-intercept, well, that's going to be 2, so that'd be 2 comma 0. To find my y-intercept, then I'm going to have to evaluate at f of 0. 0 minus 2 over 0 plus 3. That'll equal negative 2/3. So my y-intercept is 0 comma negative 2/3. Okay, next we want to get the vertical asymptote. Remember that comes from the denominator. So that's going to give me x equals negative 3. And then let's do our horizontal asymptote. Remember, we got to go through our cases. So we're going to look at each case here. So here, degree 1 and degree 1. So that's going to match case 3. So I'm going to just take the ratio of leading coefficients 1 over 1, which is y equals 1. So let's put that in light blue. Now, you might be asking, well, how do I determine if this thing crosses the horizontal asymptote? You really haven't talked about that. Well, if it does cross the horizontal asymptote, that means the y value of this has to be equal to the y value of the horizontal asymptote. So what we can do is we can set x minus 2 over x plus 3 equal to 1. And now I'm solving a rational equation. Well, multiply both sides by the LCD. LCD here is x plus 3 So when I do that, they cancel here. X minus 2 equals x plus 3. Go ahead and subtract x from both sides. I get negative 2 equals 3, which is false. So the answer is no, it does not cross the horizontal asymptote. So that's the way you can check to see if it crosses the horizontal asymptote. So let's put down what we've got. So I have this horizontal asymptote of negative 2/3, so that's about here. It's kind of a small grid. I have an x-intercept here at 2. A vertical asymptote here at x equals negative 3. And then a horizontal asymptote of y equals 1. Now, desperately need to get more information here. So we're going to use our calculator to get some additional points. Have a pretty good idea what this side's going to look like. It's probably going to look like that. The question is this side. And keep in mind when you're drawing these, as they get closer to these asymptotes, the graph has to approach these asymptotes. So for the right side, we're probably okay. We probably got what we need, but let's get some table of values. So let me go ahead and quit out of this. Let's get our table going. Let's clear this. Fraction key, x minus 2 over x plus 3. And let's see, I want to start it, let's start at negative 5. Oops. Make sure you use that negative down next to the enter key. And let's see, for step, let me clear that. Let's do it by step 1. So negative 5 is 7 over 2, that's 3.5. So negative 5, I want to go up to 3.5, so that's this point here. Negative 4 is 6. All right. Now, maybe you decide, well, I want to see what it's doing over here. Well, even though we started negative, if I hit my up arrow, I can get that point. That's negative 6. Or I can go up to like negative 7 or negative 8. Negative 8's a nice one. Negative 8 too. Let's pick that one. So now I've got 3 points. And I could just go do my down arrow to get down here. So maybe I want to take a look at negative 2. That's negative 4. Alright, so I think we have enough points here to draw this in. And I'm going to do the same thing over here. And that would be a sketch of our graph. Alright, let's try number 11. So again, just kind of keep in mind, x-intercepts come from the numerator, vertical asymptotes from the denominator. Just something to note here on this last one. Notice my power on that was 1. So the odd multiplicity, notice my graph did cross the x-intercept. Where here, my x-intercept, 0, 0. And what should happen here is that's even multiplicity. It should bounce or touch. And let me label this better. Now, if I do f of 0, well, I should get 0. In fact, we actually get something that's undefined. So something's not right. Oh, I know what we did wrong. My bad. Remember what we said earlier? So this is a good mistake to make. When we're doing these things must be reduced to lowest terms. And so everything I've done here is wrong because I forgot to reduce everything to lowest terms. So always make that as a lesson for you, is double check to make, particularly if you start getting stuff that doesn't make sense, double check to make sure you reduce the lowest term. Here I forgot. All right, so we're going to reduce this. I'm going to rewrite that 2x squared as 2x times x. I can factor out a common factor of x out of that denominator. Those x's are going to divide out. That'll give us 2x over x squared minus 4. Now normally I would say this is a vertical asymptote, but keep in mind I do have a restriction here, and I'm just going to note it over here. X cannot be equal to 0. That means I'm going to have a hole when I actually draw this graph. And we'll get to that when we get there. So, looking at this, normally I would say that my x-intercept here would be 0, 0. But this is actually going to be a hole because of my restricted value. So when I plot it, I'm going to, instead of plotting as a filled-in dot, I'm going to plot that as an open circle. Now I'm going to pretend that it actually is an x-intercept, but I'm just going to leave it as an open circle. Y-intercept, well, there is no y-intercept because x cannot be equal to 0. So technically there actually is no x-intercept either because it's actually a hole here. But I'm going to just kind of pretend that it is. So now if I look at this denominator, that's a difference of squares. I can factor it to x minus 2, or x plus 2 times x minus 2. So I'm going to get two vertical asymptotes. X is negative 2 and x equals positive 2. So let me draw those. All right, let's get the, next we're going to get the horizontal asymptote. Here my degree is larger on the bottom, so y equals 0 is going to be my horizontal asymptote. This falls under case 2. Now question, does this cross the horizontal asymptote? Well, if I set that 2x over, I'm going to leave it in unfactored form. If I set that equal to 0 and try to solve, if I multiply both sides by the x squared minus 4, that would give me 2x equals 0, which would give me x equals 0. And we already said that was a hole. All right, so we're not going to worry about that. So looking at this graph, I really don't have a whole lot of information. I need to get some more values here. So here's where our calculator is going to come really in handy here. So let me quit out of this. Get back in the table. Let me clear this. And I'm going to type in the original function just so that we capture everything. And so we can kind of take a look at what that hole looks like. maybe I'm going to start this at -5. And step 1 by 1 sounds good. All right, -5, that's -10 over 21. That's about a -0.5. So, no, I didn't plot the horizontal asymptote. That's what's wrong here. So let me put that in real quick. Y equals 0. All right, so that's about a little less than -1/2. So that would be about here. -4 is about 2/3, so that's here. -3 is 5 over 6, so that's about here. All right, so we kind of got enough information there. That should be an error. -1 is 2/3, so that's about here. Get an error. Well, that's because we have a hole there. That's good. This is a -2/3. Error at 2. And we get 5 over 6 at 3. 2/3, 4, x equals 4, and then about a half here. So I would like to have some more information here, so let me go back, quit out of this, do my table again, hit enter, and I'm going to start here at -2, and I'm going to step by 0.5. Well, 12 over 7, that's almost 2. So that's like up here. And correspondingly, if we go down to +2, we'll get almost a -2 down here. So now I've got something that looks like this. Again, it's got to approach those asymptotes. And it's got to go through these points and approach that asymptote. It's got to go through these 3 points, and it has to approach the asymptote here and here, and goes through these 3 points and approaches the asymptote over here. So that's a sketch of our graph.